All right, the point of this lesson, today's lesson, is to help you to realize that any of the methods we looked at, whether it's tables, slope-intercept, point-slope, standard form, and another one we're going to look at today, can be used to graph your line, okay? Today I'm going to focus on finding the x and y intercepts. You guys remember how we did that a couple days ago? And we're going to use that to be able to graph, which I think once you get those intercepts, very easy to graph. But you're going to see that some methods are more, I guess, more easily understood than others, depending on the problem. So example number 3 is the one I'm going to start with. I actually, at first, when I first looked at this example, I was like, are you kidding me? There is so much to do on this problem. Let me give you a hint. You're not doing problems like this on your homework. But these concepts that I will go over, they can be used in different parts of your homework. So not this big problem. You're not going to have this big problem 5 or 6 times. You're just going to have it this example. Please don't get discouraged. All right, so if you can write down example 3, graph 4/5 times the quantity 2x minus y. That's going to equal 6x plus 2/5 y minus 10. Okay, like I said before, do not get discouraged and look at this and say, are you kidding me? We're going to be doing this today. You're not taking all of this in one problem. You're taking pieces of this problem in separate individual problems. But let's go ahead and work this out because the concepts are good. All right, which form is that closest to? It's a trick question.
All of them.
I think I heard it over that all of them. Someone said, anybody?
Points.
Okay, some of you may be able to see standard form here. I don't know how, but you may be able to see it. Some of you may see point-slope form. Some of you might even somehow see slope-intercept form. I don't see it. I would say that this resembles all of them or none of them, okay? So what I want to do here is I want to make this as simple as I can get. And if you don't know what form you can get into, a good form to try is standard form. Because that is, for all of us, what do you do in standard form? What's the goal? You want to get the x and y on one side and the constant on the other. Okay, but there's a lot going on here. So what I'm going to do is this. There's this big thing that's underneath a couple of numbers that's really throwing me off.
Divided by 5. I mean, multiplied by 5.
So what do I do to both sides?
Multiplied by 5.
I'm going to multiply both sides by 5. It's like a big... And notice I put everything in parentheses. All right, listen carefully because, like I said, we're going over many concepts in this one problem, and it's going to make it easier. Why did I multiply by 5, by the way? Why 5? Like, just because?
It's the denominator of the fraction, both fractions.
Yep, the LCD of these two fractions is 5, so multiply by 5. All right. Okay, I have 5 being multiplied by 4/5, which is also multiplying 2x minus y. What happens to these two 5s? They cancel out to 1 over 1. So I don't have any 5s anymore. They're not here anymore. And this is in contrast to what's going to happen over there. So please pay attention. These will cancel out. All right, what's 4 times 2x? 8x. 4 times negative y? Negative 4y. So that's what I get on that left side. Is that better? A lot better than that fractional part. Okay, on this side, it's a little bit different. Isn't 5 being multiplied by everything here? Okay, 5 was being multiplied by 4/5 and by 2x minus y. How many factors did I have here? 3. 1, 2, 3. All right, 5 is being multiplied by this whole quantity. Technically, how many factors do I have? 1, 2. So do you see how these two can cancel out because they're two separate, like they're two factors, and one of them has a numerator and a denominator of 5. Here, you have a numerator of 5, but does everything here have a denominator of 5? No, I cannot cancel these out. I actually have to use what property? Distributive. All right, what's 6x times 5?
38.
What's 2 fifths y times 5?
10.
Positive 2y, or positive 10 fifths y, which is 2y. And then what's negative 10 times 5? Negative 50. All right, so that made it a little bit easier to look at. And then what do we want to do in this problem again? We want to get it into standard form. Because if you don't know what form to get into, standard's a good one. All right. On this side, are there like terms? And on this side, like terms. But yes, there are terms that cross over, so you have to do something on both sides. All right. Here's what I'm going to do. I'm going to get the x and y over to the right side and the constant on the left. Wait, Mr. A, I thought, isn't that switched up from standard form?
No.
Okay, let's just do this. I'm going to subtract 8x from both sides. And I'm going to add 4y to both sides. And I'm going to add 50 to both sides. And I'm doing that all in one step. So ready? Can I run through it again if you're not sure what happened? Ready? Watch. I'm subtracting 8x from both sides. Doesn't that cancel out? And then I subtracted 8x from here. What do I get? 22x. So that's now done. I added 4y to both sides. And what happens right here?
6y.
And I get my plus 6y. And I added 50 to both sides. What happens to the right? Canceled out. Okay, and then I get my 50 over here. Oh, oops. I'm so sorry, guys. That's not standard form, or is it?
Yes, it is.
Okay, what's the way we're used to seeing standard form? Yes, ma'am? 22x plus 6y equals 50. Okay? So, listen. On this step right here, where I did all this addition on both sides, you could have taken it one step at a time. You could have added, subtracted 8x from both sides, then get something. Then added 4y, get something else. Then added 50, get something else. But you can do it in one step. Okay, I get this, but here's a little help for you. You notice these numbers are kind of big? And does anyone notice a common factor in each one of these terms? There's something common to them. Claire? 2. Doesn't 2 fit into all of these evenly? How many times does 2 fit into 22x? 11x. How many times does 2 fit into 6y? 3y. How many times does 2 fit into 50? 25 times. Okay, can I ask you a question? Are these two equivalent equations?
Yes.
Equivalent means they have the same solutions for x and y. And the answer is yes. Yep, you divide both sides by 2 and you get this. All right, this is simplest form. Okay, now this is what I'm going to do today. You're really, by the way, your homework is going to give you that and then tell you to graph. So did you have to do all this necessarily?
No.
No, some problems may require you to do all this right here. Some problems may want you to get rid of the denominator, but these problems are not going to make you do it all at once. So that's nice. Standard form, love it. From standard form, I'm going to go 2 routes. I'm going to go into slope-intercept form. Or into the form we're going to look at more predominantly. Graph or graphing intercepts. How many intercepts does a typical line have?
2.
Yeah, what are they?
1.
Which lines will only have 1 intercept? Most lines will have 2 intercepts across the x and y axis, but which lines will only have 1 intercept? Right?
Horizontal or
Okay, horizontal lines will only cross the y-axis, and vertical lines will only cross the x-axis. Does that make sense? So they'll only have 1. Okay, I want to start off with the intercepts. Does anyone remember how to find, and I'm going to just work it here. Does anyone remember how to find the x-intercept? You have to make something 0. Does anyone remember what that was?
Y.
Make y equal 0. So on this equation right here, make y equal 0. Y equals 0. 11x plus 3 times 0 is equal to 25. So solve for x. All right, I get 11x equals 25. So what does x equal?
2 and 3 11.
Okay, you can call it 25 11ths, and some of you are already getting it, 2 and 3 11ths. Either one is okay. So where does this line hit the x-axis? Where does it hit my x-axis here? At 2 and 3 11ths, or 25 11ths, okay? That's the x-intercept. And I'll circle this. Let's look at the y-intercept. How do I find the y-intercept?
You change x to nothing.
Make x equal 0. So starting with that equation up here, make x equal 0. So 11 times 0 plus 3y equals 25. What does 25 thirds equal? Sorry, Jenna? 8 1/3. So whether you think of it as 25 thirds or 8 1/3, you're correct. Okay. If I have the x-intercept and the y-intercept, how many points do I have? 2. Is that how many I need to graph?
Yes.
Okay, now what you need to do on your graph paper is you're going to go ahead and think about it. Where x equals 2, that's over here on the right side, and y equals 8 1/3, that's like above. So I'm going to do this. I'm going to draw my coordinate plane, emphasizing the first and second quadrants.
How far do we need to go?
What do you think? What's your guess? If I got to go 8 1/3 on the y-axis, how far do I have to go up, you think? All the way up to
8.
like about 8 or 9. And then if I have to go 2 and 3 11ths on the x-axis, you only have to go you only have to go up to like 3. All right, that's my y-intercept. So where do I put my circle? 8 1/3 is about right here. So you see here, that's your y-intercept. What's the x-intercept? So you go 1, 2, and 3 11ths is about right there. Do you have your 2 points? All right, what do you do with them now? You connect them and you have your line. That's it. That's the x and y intercept. Guys okay with that? What was the other method we could have used on this one? Yeah, so that's what we did. Slope intercept. What was the equation up there?
It was 11x plus 3y.
Alright, let's see if some of you can remember this. This is standard form. Does anyone, by looking at standard form, know what the slope is?
Yes.
Brian knows.
11.
Oh, okay. So you're thinking it's just the number in front of x, but if this is standard form, it's a little bit more complicated. Do you remember negative a over b? So negative 11 over 3 is the slope. Right? From standard form, it's the opposite of a over b. Negative 11 thirds. Does anyone remember what the y-intercept would
C over
be?
B.
C over e. What's c?
3.
C is 25. What's b?
3.
Okay. Huh.
3 just
Is this represented up here?
yes.
Yeah, what's this up here, guys? 25 thirds, isn't that from slope intercept? Okay, ready? Down 11 over 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3. Do we have a point there? Okay, you guys get that? Either way is going to get it for you. And then the other way you could have done it is if you get this in slope-intercept form. And you know what slope-intercept form would look like? Okay, oh man, this is review. Can anyone write it to me for me in slope-intercept form right away? You're like, we can't do that right away. You have enough info. You don't have enough of what you need to put it into slope-intercept. You got to solve for y and do all that stuff, don't you? All right, Jack, what's your slope-intercept form?
Y is equal to negative 11 over 3 x plus 25.
Guys see it? See the relationship? No? Don't worry, I'll give you a chance. All right. This is what I'm going to do. I'm going to give you your homework, and then I'm going to help you out as much as I can. So, the first problems I'm going to give to you, I want you to do it in the intercepts form. You've got to find the x and y intercepts like we did up here. And then after that, the rest of them you do it whatever way you want. You can do the table if you want. I wouldn't recommend it. Yes, ma'am.
Wait, do we do our homework on the same thing?
I think I might give you a separate one because I don't want you to lose that. So if you have graph paper, great. If you don't, you have some right here. I'm gonna stop the video here, and then I'm going to stop the video.